Okay, so we didn't quite make it. We didn't quite make it with the last video, so we got to the end there, and I just didn't simplify it because it was weird. But the answer to number C, I'm sorry, letter C. I do silly things sometimes, but the answer to letter C is 2/3. I have it written here. It is 2/3 the cubed root of 4. So that is specifically what it is, I guess, in most simplified terms. You get something kind of weird like that, and you just assume that you made a mistake, but I went through it very carefully, and we don't have to simplify something like that, but that is we had the x, we had the y, and then that's the maximum when you plug it into f of x comma y, you get equals this. So that is the answer to C. Okay, so all that is left is D. Now, D cannot possibly be done in one 10-minute video. This is D, so D is done, and it's kind of weird. D is on the page, but D is basically, the function is f. If we kind of take a look, f of xy equals x to the a, y to the b. So it's a very general Cobb-Douglas, and we have, it's always xy greater than or equal to 0. We don't need that, but we do need our constraint. This constraint does specifically come from chapter 4. We just don't need that yet. It's called an isocost. I think that thing is right there. We'll learn about that later. Yeah. But, just kind of silly, silly. I can't say that. I was going to say sillily, but it takes like, a couple pages to solve this. I didn't want to do this. It's kind of one of these things where we make a U or something like that, but we do the work here. This is kind of, this region is A, then we go to B, and then we go to C, and then we go up here to D, and we have these arrows taking us finally to the answer. And just to say it, because the video will probably end fairly abruptly, that is the maximum right there. So they make it this weird thing that just comes out crazy, gnarly algebra, and we don't have to understand the physical meaning of it. But anyways, so we can kind of go over the basics. So we do need the delta y over delta x. Yes, I'm sorry, we don't start there. We start right here. If we look at that, the partial of x, yeah, this is our f of xy here. So the partial of x, the partial of the function with respect to x, I'm sorry, is ax to the a minus 1, b to the y. The partial of the function with respect to y is bx to the a, y to the b minus 1. So we have to know how to take those. And then this whole long thing here. So step 2, of course, all Cobb-Douglas follow the same rules. We don't have to know what we're doing anymore. We just have to follow the procedure. We plug into our slope formula, yes. So if we see that there, I've done all the work there. We don't really have to repeat it. You could say delta y over delta x, or we could just say m is going to be the slope of all contour lines equals negative partial of x over partial of y. So I wrote it right there, equals negative. The top one is ax, it's just these, a minus 1, y to the b, yeah, over b, x to the a, y to the b minus 1. And then it simplifies and we get this. So what is the outcome to that? The outcome is negative ay, that's a times y. A is a constant, y is a variable, b is a constant, x is a variable. So it does come down to kind of a nice, neat little thing right there. Okay, so that's the slope of that. Now we have to take our isocost, it's just a fancy name for that little equation there, and here it is here, and just solve for y, get y alone, and we get a y equals mx plus b. I hope we always remember y equals mx plus b. That's y equals mx plus b, this thing that I wrote right here, where m equals what? M equals negative px over py. A lot of us are still very iffy about just our mathematical understanding at all. Those are constants, they're not variables. Here's our thing. The x is a variable. It's our independent variable. The y is a variable. It's our dependent. Everything else, px, py, and I, everything else is a constant there. So what are we saying here? For our contour lines, this is the slope. For our constraint, this is the slope. Yeah, right here. So then I write it there. You set the slopes equal to each other, right? So that would be the next step. M is going to be from our iso cost, from our constraint is negative px over py equals negative a over b, y over x. And just, solve that. I do this little arrow thingamajiggy. We take this, take that, and get y alone. And then we get him. And I have that b written there because this kind of sort of indicates part b. And then we get him. So we get y. Yeah, what do we have? We have 2y equals. We have y equals, yeah, b over a. I don't feel like writing them. We have that. And then this is our constraint. Remember, we didn't use our constraint. We used the slope of the constraint. A silly algebra rule, I shouldn't even say it. It's very obvious that you cannot plug an equation into itself, but we're not reusing an equation. We didn't use the constraint. We used the slope of the constraint to find this. Yeah. So now we have two equations. We have him, and we do have him. Y equals a thing and y equals a thing, so set them equal to each other. We set them equal to each other, and solving for x is kind of a nightmare. So this is solving for x, and then I have an arrow going that way, and all of that is solving for x. And if you solve for x, we go all the way up to d over here. Yep. We go all the way up to d. So what is d? X equals a over a plus b I over px, all of which are constants. Nothing in there is a variable. That's all one big number. It's one big constant. Yeah. So we have y equals what? We have y equals him. So plug it on in there. Y equals b over a, px over py. The x is going to be a over a plus b I over px, and things happen like an a cancels, a px cancels, and that's why we get this thing that I have circled over here. So we kind of pause the video there a little bit. Uh, if people are interested in this problem, it is the single hardest problem in chapter 2. Just follow the steps we're doing, and we get x equals the top. We get y equals the bottom. Those are the x and y values that guarantee maximize him, f of x. So plug them in and you get that. This video, I think, has been going on about 8.5, 9 minutes. So if we want, we could plug them in. I'm not going to write it. It's f of x, comma, x goes in there, y goes in there, equals, but it's going to equal that x to the a, y to the b. So that's a over a plus b I over p of x. That's x to the a, y is b over b plus a. It's just the kind of thing that's not meant to simplify into anything nice. To the b, and I wouldn't say simplify, it's more like rearrange. You could get I to the a plus b. There is an I to the a plus b in there. So this right here, that bad mamba jamba right there, let's just kind of emphasize that before we stop the video, which is now. That right there is my final answer.